Hey guys, today we are looking at free fall. Free fall is when an object is falling, which means it has no force exerted on it besides gravity. Gravity is the only thing acting on it, nothing else is pushing on it, nothing else is touching it. It's just falling through the air, only affected by gravity. Now, on Earth, in free fall, every object has the same acceleration, and that acceleration we write as the lowercase letter g for gravity, and it equals 9.8 meters per second squared. And that's everywhere on Earth for any object. Doesn't matter the size of the object at all. Its acceleration is going to be the same. Now that number will change, like on other planets or on the moon where gravity is different. That would be a different number. But here on Earth, g, the acceleration due to gravity, is always 9.8 meters per second squared. And a weird consequence of this that we're actually going to explore later on in our next unit that covers forces is that objects are going to fall at the same rate no matter their size. And Galileo was the first person, or maybe not the first, but the first we know of, that experimented with this. And he stood on top of the Leaning Tower of Pisa, which is shown for you right there. And he dropped a feather and a brick off of the side. Now, did he actually use a feather? Probably not, because of air resistance, but something very light. But he dropped the light object and a heavy object to see which one would land first. And the answer for which is going to land first, the heavy object or the light object, is that they are going to land at the same time. They will land at the same time. And that's because they both accelerate at exactly the same rate. One doesn't go faster than the other. They go the exact same at the exact same rate, so they fall and land at the same time. So, since gravity and the acceleration due to gravity is the same for any object anywhere on Earth, acceleration is automatically given in any free fall problem as 9.8 meters per second squared. However, there is one small caveat to that, and that caveat is due to direction. So in your problems, there's two directions the object could be going. If it's falling, it could be going up or it could be going down. And that seems counterintuitive because you wouldn't think of an object falling and going up. But if you toss a ball straight up in the air while it's going up and there's nothing acting on it besides gravity, it's still technically falling. And it's still falling with an acceleration of 9.8 meters per second squared. So even though the object might be going up, the same idea of free fall still applies to it. And there's two directions, so it could be going up or it could be going down. Now, anytime you start a problem with free fall, you have to choose which direction you want to be positive and negative. The most obvious choice is positive going up and negative going down, and that's great. If that's what you want to choose every time, so be it. You can also choose positive being down and negative being up. That's also fine. It's valid. You can do that if you want to. Either way is perfectly fine. You just have to make a choice each time you work a problem, because your gravity 9.8, if it's positive or negative, will depend on your choice of coordinate system. Because gravity always pulls down. It's always accelerating downwards. So in this first coordinate system, this one, gravity goes down, so it's negative. So the acceleration would be negative 9.8 meters per second squared. But in the second one, where down is positive, the acceleration is going to be positive 9.8 meters per second squared. You have to make your gravity match your choice of direction. And either one is fine, you just have to choose. This also applies to your velocities and your displacements, which you can write as delta x or delta y since we're moving vertically, whichever you prefer. So if an object is moving downwards in this first coordinate system, it's moving in the negative direction. If it's moving upwards, it's in the positive direction, and that is flipped for my second option. If you're going over here on this second option and you're moving up, your velocity is going to be negative. If you're moving down, it's going to be positive. Same thing with your displacement. In our first system, if you go up, you're displaced positive. If you go down, you're displaced negative. Second coordinate system, if you go up, you're displaced negative. And your displacement is positive if you go down. So you just have to choose your coordinate system at the beginning of your problem. The choice is valid, whichever way you choose. And then make sure all of the signs on your corresponding variables match. And then there's one other small piece of information that you need for free fall, and it's this top sentence up here. It says, another hidden given is based on the idea that the velocity at the very highest point for an object in free fall is 0. So if you toss a ball up in the air, right when it reaches its highest point and turns around and starts going back down, right there at the tip top, the velocity is 0. It stops for one small moment, an infinitely small moment. It stops, turns around, and starts falling back down. So right at that very highest point, you can use the idea that the velocity is 0. And let's see how to apply that with this example. It says Steph Curry is working on a shooting technique by launching basketballs straight up in the air and seeing how high he can get them. What is the maximum distance he can launch the ball straight up if the ball leaves his hand at 3.41 meters per second? Side note, the answer for this is not going to be reasonable because I didn't have an accurate velocity for Steph Curry. And then I later Googled it and found his velocity is much higher than that. So we're going to work the problem as is, but realize our answer is not accurate to Steph Curry, actually. All right, first thing we need is the I is for image. It is actually really helpful to draw an image here. This is going to be my Steph Curry. This is going to be my basketball. The basketball goes up. Woo! And we're looking for the maximum distance. So we're just going to see how far it goes up. And before you can move on to your givens, you have to make sure you define your coordinate system. I'm going to make up positive and down negative. Up is going to be positive, down is going to be negative. That's my choice. If you want to choose differently, you can. So that's our image. Next, we need our givens. Our first given is this number, 3.41 meters per second. And that's going to be a velocity, 3.41 meters per second. But since we're accelerating, there's two types of velocity. There's the velocity initial, the velocity it starts at, and the velocity final, the velocity it finishes at. And the question says this is right when the ball leaves his hand. So that's going to be its initial velocity at the start of its path. And it looks numerically like there aren't any more givens, but there's a couple of things that we know. We know that gravity is always 9.8 meters per second squared. So our acceleration is going to be equal to the acceleration due to gravity, which is 9.8 meters per second squared. And then we also know one other thing. Because we're looking for the maximum distance he can launch the ball, that maximum distance, the maximum height, is going to occur right at the very top of the shot. And the top of the shot happens when the ball slows down just to a stop and then comes back down, falls downwards after it's reached its highest point. So right there at its very highest point, its velocity final equals 0. So we can use that fact as a given. And the question asks for the maximum distance, so that's going to be delta x as our question mark. All right, for the graphs, we're actually going to do a position time graph. That's this top one. I know it says YVT. That's Y for the vertical axis. Here I'm using X, but you can use Y if you want. Now it starts out in Steph Curry's hand, so that's a little bit above 0, a little bit above the ground. And it's going to go up to some highest point. But as it does that, it's going to slow down. So you got to make your graph curved and slowing down. And then for the velocity versus time graph, my velocity is going to be positive the whole time because it's moving up my whole time. But it starts off fast and gets slower. So I'm going to start off fast on the positive side of velocity and get slower over there. Perfect. So now we've got our position time and velocity time graphs. All that's left to do is equation substitution and solution. So first thing is an equation needed. You need to find an equation that has VI, A, VF, and delta X. The equation that has those things is VF squared equals VI squared plus 2A delta X. Now I just got to plug in numbers. VF was 0. VI is 3.41. I've got to square that. Plus 2 times A, which is 9.8. And then delta X is delta X. Now we get to solve that for delta X. In order to solve that, you're going to have to do a 3.41 negative 3. Sorry, I can't speak. You're going to have to subtract 3.41 squared from both sides. So on the left, you'll end up with negative parentheses 3.41 squared equals 2 times 9.8 times delta X. And then to solve that, you have to divide by 2 times 9.8 on both sides. Oof. I just realized I made a mistake. Can you see it? Did you catch it? My mistake here is that for my acceleration is going downwards because gravity. So it should be negative 9.8 meters per second squared. So I need to change this to be negative. So we're going to divide by 2 times negative 9.8. And that's going to get you a positive number. Let me calculate it up real quick. And that'll get you 0.59 meters, which is not that high. And that's not reasonable for Steph Curry. He actually does shoot much higher than that, which means this speed has to be much greater. I just made a random number. I didn't get one from an actual stat. If somebody actually gets the stat on that, let me know so I can change the problem. But yeah, to recap, because I definitely skipped over it and I myself made the mistake, you have to choose positive and negative for all of your vectors. And vectors are things that have direction. Those are acceleration, velocity, and displacement. So your velocity here, your initial one, is going up, which is in the positive direction. So you leave that as a positive number. Acceleration from gravity is negative. It's going down because gravity goes down. So you have to make that number negative. Velocity final is 0. It doesn't have a direction because it's not moving. So plus if you put positive 0 or negative 0, it still means the same thing. It's just 0. And in the end, we got a positive 0.59 meters, which meant the ball was going up, and that's what was happening. So that makes sense. All right, hopefully this video is helpful. If you need anything, let me know. I'll try to help you out. Please email with any questions you have.